moving ship. In this picture, we see a ship is affected by four forces. A and C, the upthrust force from the water to the ship, and the weight force from the earth to or on the ship. These forces, of course, they are balanced forces because the ship does not move upward or does not sink in the water, and they have the same magnitude, of course, and opposite directions. The other forces, B and D, the thrust force and the water resistance and also air resistance, these forces works in opposite directions, but they are not balanced forces because the ship in this case moves forward with a speed or its speed up. So the thrust, of course, the thrust force has a larger magnitude than the water resistance and the air resistance. Going to another part, stop ship or no movement. There are two forces only act on the stopped ship. This ship stop doesn't move, not like this one. This ship moves forward in the same direction with the thrust force. So the thrust and the water resistance and the opposite resistance in the other direction are not a balanced forces, but in this case, the stopped ship, the upthrust, what makes the ship floats, and the weight on the ship downward. These two forces are balanced forces, same magnitudes, same number of newtons, but they work in opposite directions. This one upthrust from water to the ship pushes upward, and the weight of the ship goes downward because of the gravity of the earth. Friction force in this case equal zero. There is no friction force because there is no movement. And this is something very important. Friction force generates when the object moves. When the object, in this case, there is no movement, so there is no friction force. Friction force generates when the object starts to move. Another picture in this plane, that flying, there are four forces acting on it. A and C, they work in opposite directions. B and D works in opposite direction. Let's see which couple of forces are balanced in this case. Let's discuss A and C. A is the upthrust force, the lift force that make the plane moves upward, and C, it's the weight of the plane that pulls the plane downward. In this case, if the plane doesn't go upward or doesn't go downward, A and C are balanced forces. They are equal they have, I'm sorry, they have the same magnitudes but opposite direction, so the plane doesn't move upward or downward in this case. When the plane wants to raises up or wants to raise up or wants to goes down, so one of them will will have a larger magnitude. For example, if this plane goes upward, of course, in this case, if this plane moves upward, so force A, which pushes upward, should be larger in magnitude than the weight force. If this plane moves downward, the weight force should have larger magnitude than force A. Let's discuss the two other forces, B and C. B, of course, the movement, the force that pushes, that makes the plane moves forward, and D, the air resistance or the drag force that pushes downward. These two forces, in this case, if the plane doesn't speed up, the two forces will be balanced. But in this case, when the plane moves forward and when its speed increase, the thrust force will be larger than the drag or the air resistance force. Air resistance in the parachutes. As a parachute is falling down, the direction of the movement will be the same direction of the gravity. And in the opposite direction is the air resistance that slows down the falling. Have a look on those parachutes. Does the size of the parachute affect how long it takes to fall down or not? We have two parachutes. The first one has a large surface area. The second one has a small surface area. Of course, the this parachute, which has a large surface area, will face a larger air resistance, so it will falls down slowly more than this parachute. Yes, the green one has larger surface area, so greater air resistance, which slows down the speed of falling down. To prove that, you can do this activity. Drop two pieces of paper from the same weight. One, the first one, flat paper. The second one, crumpled, and one crumbled up in a ball. Okay, you have to squeeze one and leave the second one flat. In this case, which one will fall down faster? The flat paper or the squeezed piece of paper? Of course, the two pieces of paper have the same mass, but this one has a large surface area, so it will face a greater air resistance when it falls down, so it will reach to the ground slowly. And this one has the same mass, but it has a smaller surface area, so it will fall down faster than the first one. The crumbled one fall faster as it has less surface area and less air resistance, so fall faster than the flat one, which has greater surface area and greater air resistance. This is this the previous part leads us to this part, the streamlining. Streamlining or streamlined shape, racing cyclists crouch down low on their bikes to reduce the air resistance on them. This helped them to cycle faster. In this picture, this man, this man in this picture, crouch down low, okay, to reduce the to reduce the surface area, so reduces the air resistance. They also wear a streamlined helmets or streamlined suits. These have a special smooth shapes that allow the air to flow over the cyclist more easily. Modern vehicles are also streamlined. Their smooth shape make the air resistance smaller, which allows them to travel farther on the same amount of fuel. The modern cars have a streamlined shape to reduce the air resistance. Also, if you remember that when we talk about the shape of the fish and some other animals like some birds, we said that before the fish has a streamlined shape, the bird has a streamlined shape, also the plane has a streamlined shape to reduce or to decrease the surface area and also to decrease the air resistance and make them move faster, the fish through the water and the bird through the air. Note, like this picture, note, in race cars, they reduce the surface area of the front body to reduce the air resistance and increase the speed of the car. This car, the front part of this car has a streamlined shape to reduce the air resistance by reducing the surface area that face the air. Thank you.